6 with an exclamation mark. What?
6 times 5. Oh,
Yes.
we know this.
You know this. No, it's 6 times 5 times 4. Okay. So 6 factorial is 6 multiplied by every whole number down to 1.
There is no difference, right?
Hey, just add that 2.
You can end it too, but I don't know, strictly speaking. Therefore, any factorial is that number multiplied by the number 1 less than it, multiplied by the number 2 less than it, and so on, all the way down to 3 to 1.
Would it work with a fraction?
No, whole numbers only. Whole numbers only. Just deal with whole numbers. Only works with integers. Okay. So we need to be able to manipulate it slightly. This is the definition again. So can we express something like 9 times 8 times 7 stop in factorial form? So
Probably can.
yeah, you can, yeah. And it'll make sense as soon as I do it. I'm going to say that that is 9 factorial divided by what?
6 factorial?
6 factorial, yes. Why? Because 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 factorial. What happens? Everything starts, that bit would all be the same number as that bit, so you're just dividing by 1, multiplying and dividing by 1. And you're left with what you want. So 6 will also go, 6 will go 6, 5 will divide, 4, 4, 3, 3, 2, 2, just by the same thing, so it all goes away. So the challenge now for you is to do this second example, 11 times 10 times 9 times 8, divided by 4 times 3 times 2 times 1. Can you write this in factorial? So that's your challenge now. Can you do it? Hint here, you're going to have to use more than 2 factorials. So the last one had 9 factorial divided by 6 factorial. Now we're going to need probably a third factorial to make it work. Anyone get it? It's going to be a fraction as well. It's going to be something over something, yeah. Yeah.
Can I say it again?
Yeah.
11 factorial over 28.
No, definitely not. Just think of what 28 factorial is.
Over 7.
I think what you got it right, but you should go a step further up. It's 11 factorial over 7 factorial, 4 factorial, which is not 28 factorial. Think about what that's 7 times 6 times 5 times 4. That's 4 times 3 times 2 times 1. Is that the same as 28 times 27, 26, 25? Well, you could work. You're saying that's 7 times 6 times 5 times 4.
Oh, yeah, that makes sense.
Times 4 times 3 times 2 times 1 all of a sudden becomes 28 times 27 times 26. No. You'll have a 128, but you won't have the 27, the 26, and so on.
Oh, would that be, would you have to like...
So maybe that's one thing to note from this. 7 factorial times 4 factorial does not simplify to 28 factorial. How did this work out? Well, if I did it out, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now I need to get rid of multiple parts of this. I need to get rid of 7 all the way down. Okay? So if I divide by 7 factorial, that will get rid of 7, 6, 5, 4, 3, 2, 1. That's 7. That's the 7 factorial. That's going to cancel out all that. But we have this extra bit here. This extra bit I have to put in. 4, 3, 2, 1. What's that? Well, that is 4 factorial. Does that make sense?
Could you just keep it like 11 like that?
Yeah, that's fine. Yeah. Can't simplify it any more than that. Well, you could, but it asks you to convert this particular one into factorial. So you could obviously simplify it a little bit more. The actual number would be simpler.
Can you do like factorial squared?
You could square a factorial, yes.
Oh, I get it.
It would be usually a very large number. Okay.
So you always simplify it by the greater factorial.
Yeah, you usually start with the greater factorial and then work back off that, if you're simplifying like this. These questions are in isolation now. We will deal with them a lot more when we do something called permutations and combinations. We're just looking at this in advance of binomial theorem, which if you look at your formula booklet, has factorial as part of it, one specific part of it. We'll just look at one more example and then get you guys to do some. So I have n plus 1 factorial divided by n minus 1 factorial. So I want to simplify this. You can try, yeah.
What's it called?
What would this simplify to?
Oh, wouldn't that just be n plus 1 times n?
Yeah, you're both right, yeah. Okay, if we just work out the top of this, n plus 1 factorial is n plus 1, what's the next thing it's times? 10, n, yes, take away 1. And then n minus 1, and then n minus 2, and then n minus 3. All the way down, 3, 2, 1, it'll eventually get there. That's the top. This bit? It's always multiplying by one number less until you get to 1. Always one less. So 7 factorial, that'll be 6 plus 1, 6, 5, 4, 3, 3, 2, 1. That would be divided by n minus 1 factorial. Well, what's 1 less than n minus 1? N minus 2. N minus 3, all the way down to 3, to 2, to 1, finish. Always finishes with 1. But we have some things in common here. This all the way down to this is the same as this all the way down to this. No matter what number it is, it'll be the same number. So all of that cancels with all of that, and we're left with n plus 1 times n, which is n squared plus n. Or you could have kept it like this. So we've simplified this into something without a factorial, which is useful for solving. Because if this was equal to a number, I could then solve for that number. Because it's very hard to solve when it's written as a factorial.